How's it going, Tense? So today we're going on to finding angles. We're working from slides 14 to 17 from the trigonometry PowerPoint. So from yesterday's work, what you guys did for me is you did something like this. You said tan 74 degrees equals, and you took your calculator. Now remember, make sure that your calculator is in degrees mode. So you went tan 74 and you got an answer for me. And we said that this was 3,487 to 3 decimals. Okay, that was yesterday. Now, what we're going to do today is we're going to find out, for example, tan of an angle equals 3.487. So yesterday's work, this was the unknown. Today's work is that is your unknown. Okay, and we're going to figure out now, or I'll show you how we figure out what that angle is that gives us that answer. Okay, so for example 1, they're asking us to find the angle theta. So we have cos theta equals 0.54. Okay, and they want us to round off our answers to 1 decimal place. So how we do this is we want to get theta on its own, just like a normal equation. So for example, if I gave you something like this, 2x is equal to 4, how would you get the x on its own? You would divide by 2, and you get x is equal to 2. We're going to do something very similar here, okay? But I just can't divide by a cos or a sine or a tan, okay? We have to do another method. So again, make sure that your calculator is on degree mode. And what we do, in order to find an angle, we go shift and then whatever the trig function is, in this case it's cos, so we go shift cos. Now I want you to notice what we get on the calculator there. We get this cos minus 1 on the bracket like that. That is what you're going to use if you're finding the angle. And what we put inside the bracket there is we put this number here, 0.54, close our bracket, equals. And that is our angle, so that we're working out here. Okay, so I'm going to round that off to 1 decimal place. So we get theta is equal to 57.3 degrees. Okay, if we look at question B, we have 2 tan theta equals 3.69. So what you always want to do is you want to get the trig function on its own. So if you have a look at this example here, we had only cos theta. Here we've got 2 tan theta. So I need to get rid of that 2 first. And this is saying 2 times tan theta. So what's the opposite of times? It's divide. So I'm going to divide by 2. What I do to this side, I must do to that side. So here, 2's will cancel and you're left with tan theta is equal to, take the 3.69 and divide that by 2. And we get 1.845. Okay, we want to get, now we've got the tan on its own. We want to get the theta now by itself. So how do we get rid of that? We say shift tan. And if you notice here, we're getting that tan minus 1 there. That is what we want. Put this number in, 1.845, close our bracket, equals, round this off to 1 decimal place, and we get 61.5 degrees. Okay, not too bad. Let's have a look at question C. Sine theta over 7 equals 0.141. Okay, just like what we did with this one, I want to get the trig function on its own. So we need to get rid of the 7. So in order to get rid of the 7, this is saying sine theta divided by 7. The opposite of divide is times. So I'm going to times by 7. What I do to that side, I must do to this side. So here the 7's will cancel and you're left with sine theta is equal to, I'm going to take 0.141 times that by 7, and we get 0.987. To get the theta, I'm going to go shift sine, that's the trig function, 0.987, close my bracket. There's our degrees, but I'm going to round it off to 1 decimal place, so that 5 will bump that 7 up, and we get 80,8, 80,8. All right, let's go on to the next one. Example D, and we have tan 5 theta is minus 1 equals 1,638. Okay, so just like those previous two, we want to get the trig function on its own. So what's messing us around is this minus 1. So if I take it to the other side, it becomes a plus 1. So we get tan 5 theta is equal to 2,638. Okay, now grade 10s, I just want you to notice here what we did with these first couple of examples here. All our angles here were just a single theta, 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 and theta, okay? And we just carried it down and we said theta equals over there and over there, okay? I'm going to do exactly the same thing here, but now our angle is 5 theta. So we're going to say 5 theta equals, and I go shift tan to get rid of the tan and that number there. So shift tan 2.638, close my bracket, and we get 69.2 to 1 decimal place. We still want to get the theta on its own. So this is saying to us what? 5 times theta. So the opposite of times is divide, and we want to divide by 5 to get rid of it. What I do to this side, I must do to that side. And we get theta is equal to, so I take 69.2, divide that by 5, and we get 13.8 degrees to 1 decimal place. Okay. Question E. We've got cos theta over 2 is equal to 0.838. Okay, we have our trig function on its own. We don't have like something in the front times it or plus minus something at the end here. So we got it on its own. So I'm going to bring down my angle, which is theta over 2, equals, how do we get rid of the cos? We go shift cos. So shift cos 0.838, close the bracket, and we get, rounded off to 1 decimal place, 33.1. Okay. Now, we still want to get the theta on its own. So what's messing us around? It's this 2. And this is saying theta divided by 2. The opposite of divide is multiply. So multiply by 2 to get rid of that. What we do to this side, I must do to that side. So those will cancel, and you're left with theta. And here we're going to take 33.1 times by 2, and we get 66.2 degrees. Okay, not too bad. So, grade 10s, I would like you to do exercise 5.4, number 1, A to H. Then, after that, it's K, L, O, and P for me, please. Thank you.